We start with this talk to see how to build a children's story generator application with .NET MAUI and Microsoft Azure. My name is Hector Perez, I'm a Microsoft MVP. Let's get started because we have a lot to cover. Firstly, what are we going to build? Well, the application consists of 3 main pages. The first page is the welcome page for users. The second page allows users to specify how this story will be generated. And finally, an audiobook player page that displays the image, shows the text, and also allows us to control the audio of the current story page. Some of the things we will see are how to use custom controls, animations, gradients, and audio player, and on the web API side, we will see how to use the semantic kernel, that is image generation service, and Azure's text-to-speech service to generate audio files. We are going to develop this application through various steps. The first step is to create the home page. For this page, I used a parallax effect, wherein I've layered multiple images to create a parallax effect, so I can manipulate each layer as needed. We will see how it was built in Visual Studio. Here I have the first version in Visual Studio. You can see that what I've done essentially is to create a grid, which stores different image elements. Each of these images has an associated picture, which I have previously imported. These images are located in a folder called Resources. I have an images folder and I have each of the pages, each of the images we saw in the slides, showing different layers of this final image. So what I do is overlay each of the images within a grid to control the effect from the code behind. I have also created a button that will allow us to navigate to a second window. In the code behind of this page, basically what I do is use a service called Translation Service, which is a service I have previously created. I am injecting this service as part of main page constructor. When this specific window appears or disappears, I activate or deactivate the accelerometer sensor for use or not. As part of this method, I have a method here called accelerometer on reading changed that allows me to specify how each of the images will move. Previously, as part of the translation service, I created a method called translateImage, which allows me to specify which image will be moved. And I have some configuration parameters, like how much this image will move on the x-axis, on the y-axis. I also have the duration of the animation, and what is this space over which this image is going to move. As part of the translation service, I simply have 2 methods. One allows me to limit to a certain extent how much an image can move from the area in which it is found. The method that allows me to move the image itself within the space in which it is found. In MAUI program, I simply carry out the registration of the XAML files and also the service that allows me to move each of the images. Let's go to the emulator and see the implementation of this application. This is the first implementation that I have shown you in the XAML code. And basically we can carry out a rotation, some type of rotation here, and you can see how the different images are moving, each one according to the amount specified in the translation method. That is, you can specify how much I want one image to move in relation to another image. We have this nice effect that we see here. Returning to the slides, I have defined a second step, which is to create a button with a gradient, but not a static gradient. Instead, I wanted to create a gradient that is dynamic, moving according to the number of specified gradients. To achieve this goal, I'm going to show you a second implementation. It's the one we see here. I've created a class called Gradient, which contains a set of colors so we can store the colors that will be part of the gradient. I've also created a class called ViewExtensions, which contains a method called StartAnimation. This basically affects any visual element, which will allow me to apply the effect to grids, layouts, any control like a button for example, which is what we are going to do. As part of this method, we are simply creating a new animation. Each time this animation is played, a series of calculations is performed based on the gradients entered in the method. what is done is to calculate the angle of the gradient so we can know how much the gradient is currently moving according to the gradients entered in the method. Finally, the background of the element is specified, which in this case will be the button. A new linear gradient brush is specified. To paint that gradient, as part of the properties we have some properties such as, for example, this gradient or this animation will be executed infinitely. With this simple change, what we can do is, in my case, I created a new method called start button animation in the code behind of main view. As part of this method, what I do is define a set of gradients with different colors, each to form this list of gradient colors. Finally, I create a list of gradients, passing each of the gradients and start the animation on the button called start button, which is the button we saw in the XAML code, specifying the duration of the animation and the set of colors that will be part of this animation. Also, in the view model, I created a method here that will allow me to navigate to a second page using shell, as it is the method I'm using to carry out the navigation. And through go to async, we can go to a route called settings view, which I have previously defined from app.xaml.cs. I have this method called register routes, where I carry out the registration of the settings view page with this settings view route. With what I've done, I return to the emulator. I'll start the execution of the second application, and you can see that we have this nice fade effect from the entered colors. So we have something a little more dynamic on this page, and there is a rather spectacular effect on this button. If we press the button, we can navigate to the story settings page. This story settings page is what you can see on the screen. Basically, we have three elements that we can add. First of all, what is the main theme of the story? What is the child's age? Also, what is the child's name, if we want to include it as one of the characters in the story. Let's see how I built this page going to Visual Studio. We have here the third version of the application. This page basically uses a vertical stack layout to define each of the elements, as it is a very flexible layout to define these types of elements sequentially in a stack. What I do here is create a kind of pattern, that is, I first create a label to specify the name of the section, then a border. I specify a border to give a slightly darker appearance and make the text notable against the background image that I have, since I have an image that is the background of the application being defined through this image control. As part of the border, I specify, in this case, with the first element, an editor control that allows me to specify by the user what is the theme of the story. I have a second section that allows me to enter the child's age. I have a final section that will allow me to specify the child's name. I also have a button named Create Tail that will also have a gradient effect applied. If we go to the code behind, we again have the Start Button Animation method here, allowing me to specify or apply this animation to the button. Moreover, as part of the view model of this page, that is, on the settings view model, I define a set of different properties that will allow me to receive information on how the story will be generated. We are passing, as part of the constructor, a class or an instance of fake story creator, which is essentially a class that allows me to get a story with preset data. This is primarily for performing different tests. As part of this specific class, or well as part of the story page model, since a story contains different or a set of story pages. Each of these pages contains the page number, a path to an image, the current text of the story of this specific page, also what is the audio path, what is the path of the audio file that will be played. I then pass this instance as part of the generate story method, start or rather consult this service that I have previously shown to create the story with the data entered by the user and received in a variable called story. I'm also using the pop-up service called MopUp, and essentially I am showing a pop-up called loading pop-up, which is a page that I have previously created. This page contains two elements, a Skia animation control and a label type control. As part of this animation, I have to thank Ahmad Jalawani, as it is thanks to him that I obtained this animation that looks quite spectacular. Once we are displaying the pop-up to the user, we do a task.delay to simulate that we are consulting the web service, remove the pop-up, and navigate to the next page that will display the story's information. It's worth mentioning that as part of the pop-up in the code behind, I've created a method called startAnimation. It once again contains a type of fade-in animation that allows me to show and hide this control label to give it a more beautiful animation effect. Finally, in app.xaml.cs, you can register the last page, which is story view, with the route story view. With the changes that we've made, let's go back to the emulator and look at the third application, or this third version of the application. Okay, we have the main page here. We've got this button. If we press the button again, it will show us this beautiful application that you can see on the screen. It showcases the Lottie animation, which looks quite good. It also shows the animation over this label. This gives us the feeling that something is happening. The story is being generated, and finally, we navigate to the last page, which will show us the story as such. Let's move to the fourth step, which is creating the story player. This story player is a page that contains three main elements. We have an image at the top of the current page. We also have a custom control that shows us what is the current page of the story. We also have the text of the current page of the story. And finally, the player, which will allow us to control how the audio file we are generating will behave. Let's see how this page is created. Now, going to the fourth version of the application. One of the first things to note is that I have created some custom controls. I leave a reference at the end of the slides about a page where there are more resources relating to the entire process of creating this application. Basically, what I've done here is to create a custom control called progress bar, which contains a set of different bindable properties to be able to bind from XAML code or to modify how this control will behave. Here I carry out the implementation of C# code using Skia# to determine the background image first. Meaning, for instance, for the case of... I'm going to quickly go back to the slides. In the case of this custom control, we have this line in the background that allows us to specify the base color, and we have a second control that is drawn on top to display the current progress. So this first general line, this first complete line, so to speak, is drawn through this method called drawBase. We have the second method called drawProgress, where the information related to the control itself is passed to carry out the drawing of the control that goes over the base control. So what is done here is to carry out the drawing. For instance, in this case, this rectangle is very simple to draw, just using the specified colors to draw this first control. And in the second case, for the progress, some calculations are carried out using the entered information, creating a linear gradient. The gradient is drawn here, using gradient colors specified from the XAML code. I also created a second control called Circle Progress, where once again different bindable properties are created. Only in this case, some additional data such as the angle are used to calculate how much of this circle that goes outside of the player will be drawn. If we zoom in on the control, you can see that we have a primary control that shows the current status of the player, and on the outside we have a second control which displays the progress of the current audio file. This external control is what we are going to draw using Skia#. So we do this through this set of methods. We draw the background circle, we draw the progress of the circle using all this code that you can see on the screen. Another thing we do is that as part of the view model of the story view model, which is the playback page, we have defined certain properties, such as the property that will allow us to maintain the set of story pages, the property that allows us to know which is the current page of the story, the audio position, the story progress, some additional data such as the duration of the current audio, the font used or the font icon used for the player. We have some commands that will allow us, for example, to play an audio, skip to the next page, skip to the previous page, navigate certain amount of time forwards or backwards. We also have a method called applyQueryAttributes that allows us to receive information from the settings page and assign that received data from the current page to a property called story, so we can know what the current story is. As part of the implementation, we have, for example, display or pass audio method, where we simply change the current state of the player. If we need to pass it or play it, what is the player's current icon? We also have a method to load and execute the audio to play it. Here we set up some things, for example, what happens when the audio file changes every second, what happens when we execute that audio file second by second, what happens when the audio playback is finished, etc. We have a method that allows us to unload an audio. We have a method that allows us to check what happens when we skip to the next page, whether we have reached the end of the story or not. In case not, the story progress is simply updated, and the execution of the next audio file is carried out. Otherwise, the user is asked what they want to do, whether they want to restart the story or create a new fairy tale. We have some methods like this one that allows us to update the current progress, a couple of additional methods that let us understand what happens when the audio file changes second by second. In this case, we simply update the audio position property to alter the value of this custom control. So it's a view model that essentially enables us to handle the audio player. In the case of story view, which is the graphical page of the app, or from the current page, we simply define a set of regions. For example, the section for the top image. We also define a section for the part of the custom control, which enables us to know the current page. A section for the text part. We also have a section for the audio player. Here we define a set of different columns. We use label controls to display different icons to perform different tasks, except for the central control, which uses the custom control, which is the control found on the outside, that one that shows what is the current second of the audio file. For the central control, which enables us to control whether the file is passed or playing, we use a button with some characteristics to make it rounded. So this is the main page of the audio player. In the part of the code behind, what we do here is subscribe to the property or this property changed, with the purpose of knowing when the image has changed and being able to create a scaling animation to give a more dynamic effect to that top image so it doesn't look static. We also have here the override of the onAppearing method that will allow us to run the onAppearing method from the view model. Let's look at the view model. The view model defines a set of properties that allow us to receive information from the user. The important thing here is that this generateStory method is now allowing us to create a new instance, a new navigation parameter dictionary that allows us to send information to the next page. Indeed, from the configuration page, we're going to send all this information entered by the user to the player page through shell.current.goToAsync, passing as an additional parameter this navigation parameter. Let's go to the emulator. View default version of the application. Okay, here we have the application. Let's click on this button. This allows us to start the simulation of creating a new story. Okay, and now we have this nice player that you can see on the screen. We have the image, we have the section that shows us the current page, we have the story text, and the nice player that already allows us to play this specific story. We quickly return to the slides. The last part of the application is to create the story generator service. Basically, for this, we will use something called Semantic Kernel, which is an open source SDK framework that allows combining AI services like OpenAI, Azure OpenAI, and DALL-E with programming languages such as C# and Python easily. With this SDK, you can create pipelines as complex as you need to automate tasks, like in the screen example, in which Semantic Kernel is asked to create an automation to generate an email, choosing the best plugins to achieve the goal, such as retrieving project information, creating a response with GPT-4, and sending the email. In our case, we will use the Semantic Kernel for text creation, storytelling, and image generation. For the audio file creation part, we will use the Azure Text-to-Speech service, which is quite easy to use. To accomplish this, we will proceed to the 5th version of the application in Visual Studio. What I've done here is add a new project as part of the solution, called magictails.api. As part of this API, we have the program.cs file, which contains highlighted information such as we are adding a new instance to carry out the semantic kernel configuration through create kernel. This is a configuration class that allows me to specify the different values so that the service can function. Here we carry out the configuration, as we want to use the chat completion service. We also want to use the image generation service. We construct this object as such, in order to use it in this post or within this action post. Here we receive the different data of the story generation. We also receive the kernel instance that we previously registered. As part of this method, we are using a new instance of something called a story handler, which is a class I previously created. Let's quickly review what it does. Well, here, as part of the kernel, the information allocation takes place to be able to use this kernel. If we go to the create story async method, we see that we receive the story parameters here. As part of the semantic kernel, we simply use a concept called plugins. Here I have created the plugins folder. I define a set of plugins named Fairy Tales plugins. Plugins meaning here I could have a set of different sub-plugins. One plugin from this folder is called Story Creator. Each semantic plugin that we need to use will be configured by a JSON file and also a text file. In our case, our plugin will be made up of this prompt, which we are seeing on the screen. This prompt is very specific, in which we specify what we want to create. We want to create a fairy tale for children of a certain age, whose main theme is an input string. We are also indicating what the maximum word count for this story is. We specify how the description of the image on this page will be. And finally, we are indicating that we want a well-formatted JSON string to be returned where the image description is not empty. As part of the configuration file, we enter the different variables that will be part of this prompt. With this, we can now use this specific plugin that we see here. We are indicating that we want to execute the kernel using the variables that were defined or obtained from the story request information. Here we are extracting the story theme, the child's age, the child's name, the number of words, etc. With this information, we execute this method called story plugin story creator. We receive the story that, remember, returns a well-formed JSON file. We deserialize it. Here, we invoke the method that allows us to carry out the generation of different images, where we pass the previously generated image description. This returns or assigns a path to each one of the images. So we complete this object, story pages, with each one of the descriptions. We also execute a method called fillSpeechAsync, where we again pass the set of the story pages. Here, basically, we generate and synthesize each one of the audio files. This synthesize method returns a stream of audio file that we are generating from the text, and we are using a girl's voice that is part of the service to have a better story. Also, this stream we are receiving from the synthesize method, we are uploading to an Azure blob with the purpose of uploading it and obtaining a URL of the final generated file and being able to assign it directly to each of the story pages objects. Once we have done this, we simply return story pages which already contains all the field information about the images and audio files. What I have also done is that in the settings view model file, instead of receiving a fake story creator, we receive story creator, which already generates the story as such. We send all this information to the final page of the story creator. As part of the story creator, which is basically that service that allows us to obtain the story information, we assign the URL, make a post async with the user's information to the URL, and fill in the information, or we return the information of the created story once it has been deserialized. With what we have done, or this change that we have made, we are going to go back to the emulator. We run the 5th version of the application. Here we have it. I'm going to click on this button. I'm going to enter a very simple prompt. For example, a monkey that wanted to learn .NET MAUI. I'm going to change the child's age to match, for example, a 6-year-old. We will let artificial intelligence create a new story for us.
Once upon a time, in a lush jungle, there lived a curious and clever monkey named Milo. Milo loved to explore and learn new things. One day, while swinging from tree to tree, he overheard the animals talking about a magical technology called .NET MAUI. Intrigued, Milo decided he wanted to learn all about it. Milo searched high and low for someone who could teach him .NET MAUI. He asked the wise old owl, the speedy cheetah, and even the mischievous parrot, but no one knew anything about it. Feeling a little discouraged, Milo sat down on a mossy rock, inspiring others to follow their dreams. And so, Milo's journey to learn .NET MAUI not only brought him knowledge and success but also brought happiness and progress to the entire jungle. From that day forward, the animals and people lived harmoniously, using technology for the betterment of their lives.
With this, you can see that the story has been created from scratch. The text, images, and audio files have been generated, which provide a pretty impressive experience. As part of the additional resources for this presentation, I share my Twitter handle, which you can follow if you wish. I also have this post on my blog where I talk more about how this application was created. I also share my YouTube channel. As additional resources or sites, I can share or leave the GitHub of Javier Suarez, who uploads various resources related to .NET MAUI quite useful. Also, if you want to learn more about semantic kernel, you have this page that you can see on screen, where you can learn everything related to this technology. Finally, if you want to know how to create custom controls, you can visit the SkiaSharp repository, where you can learn more about this. Well, I hope you enjoyed the presentation a lot and continue to have an excellent .NET Conf.